Okay, good morning class. So today we're looking at analytical geometry and we're looking at the examples for exercise. It's 4.2. Okay. And that's on page? The exercise 4.2 is on page 88. Okay. Page 88. Alright, however, this example is on page 86. Alright, so the gradient formula we have been exposed to in grade 10 and grade 9 as well. We know that your formula for gradient is y2 minus y1 over x2 minus x1. We also know that if lines are parallel, gradients are equal. Lines are parallel, gradients are equal. If lines are parallel, then gradient 1 is equal to gradient 2. We know if lines are perpendicular, then gradient 1 times gradient 2 is equal to negative 1. Nothing about the sum either. And thirdly, if points are collinear. What does that mean? When you say the line the same line. Lines are collinear, then the gradient 1 is equal to the gradient 2. What does collinear mean? Lines are the same line. And anywhere along that line the gradient is the same. Okay, very important to note. Okay, so let's go. The first question says, example, if m, which is 6 and minus 2, n is 3 and 5, p is 1 and 9, and q is 4 and 2 are 4 points in the Cartesian plane. Show that mn is parallel to pq. People, if lines are parallel, what do we know? Gradients are equal. So we must prove that the lines are parallel, we then prove that the gradients are equal. Okay. So note that if two lines, okay, it's exactly what they're saying there. So the gradient of mn, we're going to work out, which is y2 minus y1 over x2 minus x1. So there's mn, so it's going to be 5 minus 2 over 3 minus 6. 5 minus 2 is 7 over negative 3. Okay. If I'd gone with 2 first, it would have been negative 2 minus 5 over 6 minus 3, which is negative 7 over 3, which is the same. So if you made that x1, y1, x2, y2, no problem. If you go the other way around, it's also no issue. However, if you choose that to be x1, that must be y1, x2, y2, and so on. Okay, you guys okay with that? Otherwise your sign is going to be wrong on your, what's the name? No? On your gradient. Alright, so we must now work out the gradient of PQ. Okay, so PQ is going to be 2 minus 9 over 4 minus 1. If the answer is also 7 over negative 3 or negative 7 over 3, whatever, it would be the same thing. Not so, it would have been parallel. So on top in the numerator I got negative 7 over 3. Can you see it's the same? So what do I say? Since the gradient of mn is equal to the gradient of qp, which is equal to negative 7 over 3. Therefore, mn is parallel to pq. Guys got it? Any confusion so far? Let's Let's carry on to the next example. Is that right? No. Is now example 2, and example 2 is on page? Huh? Same page. Okay, nice. Thank you. So here we told example 2, if A is negative 1 and 1, B is 2 and 4, C is 4 and 6, are 3 points in the Cartesian plane. Show that A, B and C is collinear. What do we say? What are collinear points? Points that lies on the same line. So if points lies on the same line, will have the same gradient. So we're going to calculate the gradient of AB and BC or AC. Now if you have 3 points and 2 of the gradients are equal, automatically the third will be. Not so. What third am I referring to? If you got this line here, which is those 3 points. If you got A, B, C. If the gradient of AB is equal to the gradient of BC, automatically it will also be equal to the gradient of AC. However, if the gradient of AB is not equal to the gradient of AC, then the gradient of BC also won't be equal. You guys understand? So to prove that 3 points are collinear, we only prove that 2 gradients are the same. Okay. And the third one will be automatically equal if it's parallel, and it's collinear, and not equal if it's not. Okay. So the gradient of AB I'm going to work out. How do you work out gradient? Change in y over change in x. Okay. So AB is going to be 4 minus 1 over 2 minus 1, which is 3 over 3, which is 1. Now we're going to work out the gradient of BC. Change in y over change in x. Again, I don't have to write the formula down again. Okay. So it's going to be 6 minus 4 over 4 minus 2. I'm going with those points there. Okay? 6 minus 4 is 2 over 2, which is 1. So are they equal? So what do I say? Since the gradient of AB is equal to the gradient of BC, which is equal to 1. Therefore, A, B, and C are collinear. Any confusion there, people? You all understand? Right, let's do example 3. Example 3 is on page 87. Okay. So we are told if PQ is perpendicular to RS. What's the difference between this and when we have to prove it? Yeah, they're telling us it's perpendicular. So the condition is there. We know that PQ times the gradient of PQ times the gradient of RS is minus 1. You understand? I can use that in my calculation. However, if they ask you to prove that it's perpendicular, I can't use that fact in the calculation. You understand? So here if PQ is perpendicular to RS and PQ is equal to negative 2 over 3, write down the gradient of RS. People, we know that the gradient of PQ times the gradient of RS is negative 1. Okay? People, that's a lowercase n, no? Small n. So the gradient of PQ is negative 2 over 3 times the gradient of RS is equal to negative 1. So what is the gradient of RS? Run your calculators. It's going to be negative 1. Negative 1 divided by negative 2 over 3. So they give you 3 over 3. People, if you could have seen straight, so there would be 3 over 2, I could have gone straight into the solution. Okay, you guys understand? Okay. Look at example 4. Example 4, we are told if A, 6 and 0. B, which is 3 and 8. C is 7 and 5. And D, which is negative 1 and 2, are 4 points of a thin plane. Show that AB is perpendicular to CD. So can I use the fact if I multiply it together it's minus 1? No. I must prove that it is minus 1. So this is a proof that or show that question. Okay. So let's go. They want you to prove that AB is perpendicular. So where do we start? We start with working out the gradient of AB. How do you work out the gradient? Y2 minus y1 over x2 minus x1. So AB. So what do I say? 8 minus 0 over 7. Sorry. What is this? 3 minus 6. What is 8 minus 0? 8 over negative 3. Not so. If I work out the gradient of CD and the gradient is 3 over 8, I've done the job. Not so. So let's see. So you're going to work out the gradient of CD. So let's work out the gradient. It's going to be between these 2 points now. It's going to be 2 minus 5 over negative 1 minus 6. What's 2 minus 5? Negative 3 over negative 8, which is 3 over 8. So hang on. This is good. So what do I say? Since, yes, good start. The gradient of AB times the gradient of CD is equal to 8 over negative 3 times 3 over 8, which is equal to negative 1. Therefore, AB is perpendicular to CD. Okay. AB is perpendicular to CD. People, any confusion there? No. Okay. Another one. Example 5. Example 5 is on page 88. Example 5 we are told E is a point negative 3 and 7. If it's a point 6 and P. The equation of the line L is 4y minus 9x equal to 8. Determine the gradient of the straight line L. Right. How do we... So this is the equation of L. So it's 4y minus 9x equal to 8. How do we calculate the gradient of that line? Firstly, the line must be in the form of y equals mx plus c. So is that in the form? No. So we take it 9 over. So 4y is equal to 9x plus 8. What do I do now? Divided by 4. Because if it's in the form of y is equal to mx plus c, the coefficient of y is 1. Can you see that? It's not 4 or anything other than 1. So y is equal to 9 over 4x plus 2. So what is the gradient of L? Therefore the gradient of L is 9. Okay. You guys okay? The B part of the question says the gradient of any line that is perpendicular to L. So the gradient of any line which is perpendicular to L. So what do we know then? The gradient of that line times the gradient of L is equal to negative 1. Not so? So we got the gradient that we're looking for times 9 over 4 is equal to negative 1. So the gradient they're looking for is, put in your calculators, let's see. Negative 4 over 9. People, you just do this quickly. If the gradient is 2, what is the gradient of the perpendicular line? I'm just going to look for the perpendicular. It will be negative 1 over 2. No? The additive inverse. Additive reciprocal. Inverse reciprocal. What if the gradient is 5? The gradient is going to be negative 1 over 5. If the gradient is 6 over 5, it will be negative 5 over 6. What if the gradient is negative a third? It will be 3. What if the gradient was negative 8? 1 over 8. You guys understand? Okay. So instead of going through this whole thing as I did in B now, you could have just said the gradient is simply going to be, if the gradient is 9 over 4, the perpendicular gradient will be negative 4 over 9. So I didn't have to do this calculation. You can do with me. Let's look at C. Okay, the gradient of EF in terms of P. So the gradient of EF. Did we just change the color yet? So in case you get confused here. The gradient of EF. How do you work out gradient? Gradient is change in Y over change in X. This is, remember, that is E, no? EF. So what do I write? P minus 7 over 6 plus 3, which is simply P minus 7 over 9. If you had gone the other way, no problem. It would have been 7 minus P over minus 3 minus 6, which is 7 minus P over negative 9. It's the same thing. You all agree? Because if I swap this around, a negative comes out, and that of course cancels, which is P minus 7 over 9. Okay? So either or, you should get the same answer. Okay? So what's the next question? It says determine the value of P if EF is perpendicular to line L. So if lines are perpendicular, what do we know, people? Product of the two gradients is negative 1. Product of the two gradients is negative 1. So let's go. This is now D. The gradient of EF times the gradient of L is equal to negative 1. So what's the gradient of EF? 9 minus 7 over P minus 7 over 9 times the gradient of L, which is 9 over 4, is equal to negative 1. You all agree with that? I divide both sides by 9 over 4, it's going to be P minus 7 over 9 is equal to negative 4 over 9. Or you could have gone straight and say P minus 7 over 9 is equal to negative 4 over 9, because we have calculated it in our previous question anyway. One of our previous questions anyway. So what do we do now? What do we do now? We will cross multiply. So that's going to be 9P minus 63 is equal to negative 36. Or if you could have seen from here already that P is 3, could have done, could have gone with that already. So the denominators are the same anyway. So it's going to be 9P is equal to negative 63 plus 63, Negative 36 plus 63 gives us 27. Divided by 9 is? Okay. You guys understand? Alright. So with that, you should be able to do exercise 4.2. Okay. Stop the video at this point.